So we have a bunch of equations and a bunch of graphs that we want to match together. This is the type of thing that I would definitely want to explain this all at once because I will use a process of elimination to help me out. So as I look at each of these equations and consider these graphs, it's a little overwhelming at first. So I'll say I would definitely want to keep track of what kinds of equations are going to be growth and which ones will be decay. And with me, I have to keep in mind that growth functions look like this and decay functions look like this. And I also know that growth functions are anytime that base is more than 1. So all of these guys, 1 through 4, each one of these equations is some kind of growth function. And then these functions down here where the base is between 0 and 1, they'll all be decay. And that'll help me match things together. This very first function has absolutely no transformations whatsoever. It's just y equals 4 to the x. That base is 4. So I know to look for a graph that has a key point of 0, 1. And also goes through if x is equal to 1, y would equal 4. No up or down shift, no left or right shift, and it's going to be growth. So this graph is decay, it's not correct. This graph is growth, but I can see it shifted to the left. This graph is growth, but I can see it shifted down. This is decay. Here's one. This is a exponential growth graph. This point has not been shifted, it's through 0, 1. This is through 1, 4, so that's going to be the correct choice. On to this next one, it's growth again, and this -1, based on where it's placed, means that the graph is shifted down. Up and down shifts are always easy to spot because if you look at the notes, we know that these growth and decay graphs always have an asymptote at 0 unless they're shifted up or down. So this graph will be the graph that levels out at -1. So this is up. This is shifted up 2, which this is shifted down 1. And all you got to check now is to make sure that if I were to shift it back up 1, would this point have been through 1, 4? I could see that that's what would happen. So this is choice C. This graph has a negative in front of it. That is a reflection over the x-axis. It would have been growth. Growth looks like this. If you reflect it over the x-axis, it looks like this. So I'm looking basically at either h or m for this one. When I consider both of these functions and imagine how they might look if I reflected them back to where they were originally, this is a decay function that's been reflected. This is the only growth function that's been reflected. This has got to be correct. And now I have a growth function that's shifted to the left. So this is decay. It's not correct. Here's a growth function. This is the point that normally be at 0, 1. It looks to me like it's been put 3 to the left. That's choice B. Let me cross these off as I find them. You're not. I've used you. I've used you. I used you. And I've used you. Now onto the decay functions. For all of these guys, we want to consider what happens when x equals -1, because we know that if we take any fraction to the negative power, it has the property where it flips that number over. So 1/6 to the -1 power is equal to 6. I'm looking for a graph here that goes through -1, 6. And it's decay, it's not shifted up or down, it's not shifted left or right. You're decay, but you've been pushed up, so forget you. You're decay, and you've not been moved up or down at all, so you might be correct. If x is -1, y is 6, cool beans. This is that bum. Here's another decay, not shifted up or down, not shifted left or right. If I plug in -1, I get a y value of 2. So again, I'm looking for a decay graph that's not been moved up or down or left or right at all. This is a graph that's decay. This is a graph that's decay, but this one's been shifted over. This one, -1, 2, that's got to be correct for this guy. Boom, boom, shazam. And the last guy is a decay graph that's been shifted based on the placement of this number, either left or right 3 units, and it'll be the opposite of what you assume. So this has gone 3 to the left. That's what this graph has done right here, choice K. So I hope that it kind of helps you understand how to do this kind of stuff. All you got to do is practice and think. I think that's all you got to do. Yeah. Good luck.